Here we're trying to find the derivative of arc cosine, which is another way of saying inverse cosine, using implicit differentiation. So that looks really difficult, but maybe it isn't that difficult. So if we start with the function we're given, y equals cosine inverse of x, we can rewrite that as something that we're more familiar with, which is y, or x equals cosine of y, because that's what it means for y to be the inverse cosine of x. It means x is cosine of y. And this we can differentiate implicitly. We can differentiate each term separately. There are only two terms, but we can still differentiate each term separately. And remember, with implicit differentiation, whenever you differentiate with respect to y, you need to multiply by dy by dx. So I'm going to differentiate the x, differentiate the y. So the derivative of x is simply 1. The derivative of y is minus sine y, but then I need to multiply by dy by dx. So to find dy by dx, I just divide 1 by negative sign. So dy by dx equals minus 1 over sine y. And that's another way of saying minus cosecant y. So that was actually easier than it looked. We managed to find the derivative of the arc cosine function. So that was part A. It then goes on to say, hence, that means using dy by dx you found, find the equation of the tangent at the point x equals half. So the equation of the tangent is basically a line. So we can use the general form for the equation of a line and say y minus y1 equals m times x minus x1, where m is the gradient of the tangent is equal to dy by dx at that point. X equals, was it pi over 4? Oh no, it's 1 over 2. At the point x equals 1 over 2. So we need to find dy by dx. We've fortunately already done that. So it's minus cosecant. So we can say it's minus cosecant y. But we know x, we don't know y. So I suppose we can use the original expression y equals arc cosine x to find y. So if we say y equals arc, well, let's use the more familiar notation, cosine inverse of x. So y1 equals cosine inverse of half. Cosine inverse of half is pi over 6. Make sure you always use radians for this kind of thing. Okay, so now we know y1. That can go in there. So we want minus cosecant of pi over 6. Again, that's just 1 over sine pi over 6. Now, sine pi over 6 is half, so that's going to be negative 2. So we've just found the value of our gradient. It's negative 2. We know x1, it's going to be half, and we just found y1, pi over 6. So last step, we can say y minus y1 equals m x minus x1. So I'll say y minus pi over 6 equals 2 times x minus 1 over 2. Then I'll just multiply that. So I'll have y equals 2x plus 1 or minus 1 plus pi over 6. So I've moved this to the other side by adding pi over 6 to both sides. And that's the equation of the tangent. So that's your final answer. So if you didn't need it in exact terms, you could add that in your calculator, but that's the exact equation for the tangent at the point x equals 1 over 2. So what we did was implicit differentiation, but we didn't even try to differentiate this because cosine inverse is unfamiliar to us. So I rewrote this, making x the subject. It's as if I took cosine of both sides. So I took cosine of the left-hand side to give me cosine y, and cosine of the right-hand side to give me x. Then I used implicit differentiation to actually form that equation. I could have, if I wanted to, found dx by dy, and it would have been the same. I would have got the same answer, but the question specifically states to use implicit differentiation.